Okay, 9a, let's find the second derivative at 1, 2. We're given the first derivative, so to find the second derivative, we just need to take the derivative of that. Alright, so the second derivative is the derivative with respect to x of the first derivative with respect to x, which is the derivative with respect to x of 1 over xy. So how do we want to do that? We could rewrite it and then use the quotient rule, or we could rewrite it this way and use the product rule. I think I'll do that. I'm going to use the product rule. So taking the derivative of the first one multiplied by the second factor plus the derivative of the second factor multiplied by the first factor. Okay, and then at the point 1, 2, when x is 1 and y is 2, we have the following, which is negative 1/2 minus 1/4, or in other words, negative 3/4, which is not the answer that I was expecting. So either I made a mistake or the textbook did. I love it when I make mistakes so that we can learn from them. So let's see if I made a mistake somewhere. So have you noticed my mistake yet? It's a very common mistake for high school calculus students. Notice we're taking the derivative with respect to x. And notice that y is a function of x. So when we take the derivative with respect to x of the function y to the negative 1, and we get negative 1 times y to the negative 1 minus 1, we have to use the chain rule right there, and that's where the mistake occurred. So the derivative of that second factor is negative 1y to the negative 2 multiplied by the derivative of the inside, which is y prime, times x to the negative 1. All right, and we know that y prime is equal to 1 over xy. So we'll make that substitution. So we have minus 1 over y squared times y prime, which is 1 over xy, times x to the negative 1. Or in other words, 1 over x squared y cubed for that second term. Now we can plug in x equals 1 and y equals 2. So we have a negative 1/2 minus 1/8, which is negative 4/8 minus 1/8, which is negative 5/8. And that completes 9 part A. So there's a couple things in part B. One that's really basic, and then there's one that a lot of students, for some reason, have a problem with each year. That is explaining the reasoning on why our tangent line overestimates or underestimates a y value for a given x value. First, let's start with the easy part. The equation will use point-slope form. We know the slopes formula right here, and we know the point is 1.12. So the slope at that point is 1 over 1 times 2. The slope is 1/2. So the equation is y minus the y value of that point equals the slope times x minus the x value of that point. All right, so this tangent line, y equals 2 plus etc., is an approximation of our function when we are near the point x equals 1 and y is equal to 2. So we can make an estimate near x equals 1. They're asking us to do this estimate. And we can approximate that value using the linearization, the tangent curve. So 2 plus 1/2 times 1.1 minus 1, which is, this difference is a tenth. A tenth of 1/2 is a 20th. And if you multiply a 20th times 5 over 5, you get 5/100ths. So 0.05 plus 2, 2.05. Now, here's the part that a lot of students are unable to do each year. By a lot, I mean maybe a fourth of my students. Let's explain whether this approximation, when x is 1.1 of our f value, is a little too big or a little too small. and thus explain how we know that is either too big or too small. We can answer this question very quickly by saying, since the second derivative is negative, our estimate is bigger than the actual value. But why? First of all, how do we know that the second derivative there is negative? Well, we found the second derivative in part A, and when x is 1.1, that part is positive, and our estimate should be relatively close because 1.1 is pretty close to 1, and y is positive. And so if x squareds and y's are positive, this will definitely be a negative value. We have a negative minus a positive, which will make it even more negative. So why is it that if the second derivative there is negative, our estimate is an overestimate? The College Board doesn't actually require that you explain that, but you should be able to. And here's a quick explanation using the geometry of the graph. If the graph is concave down at 1.1 and we're using the tangent line at 1 to estimate where the yellow graph is when we move to 1.1, then since it's concave down, you can see that the tangent line is on the outside, and the tangent line in black will always be a little bit above the curve when you move away from it. So our estimate of 2.05 was up here, which would be a little bit greater than the actual value of f of 1.1. All right, finally, let's find the solution when y is 2, when x is 1. All right, we will need separation of variables, and then we'll substitute stuff in, so that should be pretty straightforward. Separation of variables, antiderivatives, multiply both sides by 2. Take the square root of both sides. Substitute in our point when x is 1, y is 2, and solve for c. Square both sides, and there we have it. Y equals positive or negative square root of 2 times the natural log of x plus c, which is 4.